Hello everyone, my name is Blane Stacy. I'm a soil health and rangeland management specialist for the Oklahoma Conservation Commission. And today we are going to delve into the depths of soil health. Thank you all for attending or watching. Let's go ahead and dive right in. The first question I'd like to ask everybody is, what is soil health? A lot of people have a lot of different answers, but Webster's Dictionary defines soil health as a state of the soil that meets its range of ecosystem functions as appropriate to its environment. That covers a spectrum from subtropical environments near the equator, lots of moisture, lots of sunlight. The same parameters that define soil health may be different according to ecoregion or ecotype, but the principles remain the same. It's that soil has that inherent ability to function the way the ecosystem allows it to. When we discuss soil health, we've really come up with 5 core principles of soil health, and those are defined here. We'll start from the top. Number 1, keep the soil covered. That is, always maintaining something to keep that soil protected. Number 2, minimize disturbance, reduce the amount of physical impact on that soil. Number 3 is try to maintain a diversity of plants in a native prairie that's really prevalent. Native prairies have a very diverse plant community, upwards of 150 to 200 different plant species in the majority of intact plant systems. Number 4, keep a living root in the soil. We say year round, but as long as the year as possible. And then soil health principle number 5, that is to incorporate livestock. A lot of the soils in the world evolved with animal impact. So reintroducing that principle in a lot of soils that haven't seen animal impact can have some pretty positive results. Then there at the bottom, I always like to throw this quote from Gabe Brown, a soil health pioneer from North Dakota. He says that we can improve soil health so much faster than we used to think. It's just a matter of following the principles of nature, which in this case are the principles of soil health. So soil health principle number 1. I don't like to pick one principle over the other in terms of importance, but we put this one at the top because this is the one that's most easily remedied. And that is keeping our soil covered. Now the data is a little bit dated from this first fact, but the average national soil loss from the USDA in 2007 was 4.8 tons per acre. So that 5 tons of soil was leaving and never coming back. That is unacceptable to me. Certain conservation agencies, they set an allowable soil loss tolerance. My soil loss tolerance is 0. We should not lose any soil at all. And if we are, to me, that creates a resource concern. And a lot of our soil loss is based on our traditional cropland management. We plow or harrow or disc that soil. We break that soil up and fluff it up. And then if we don't get a nice soft rain, if we get a big storm, a large rain event or a large wind event, that soil is picked up and carried away. So when we talk about keeping that soil covered, maybe changing some of our crop rotations or how we prepare our soil or seed, no-till or minimum till is a really important one. Maybe changing up our crop rotations, switching to crops that don't require soil being uncovered to facilitate that. But keeping our soil covered is a problem in some of our grazing land as well. Overgrazing in a continuous stocked system, cows or other livestock continually seek out the more palatable plants. Those plants are reduced in their structure, they're reduced in their composition. That opens up soil. So we can manage our rotational grazing plan. We can do some forage management planning. Even in some of our urban settings where we're looking at more holistic lawn care ideas instead of mowing our grass very, very short, scalping it off, letting it thatch out, letting it grow, letting it protect that soil. This is a presentation that if you get the opportunity through either through your local conservation district or other avenues, this is a picture of our rainfall simulator. And what we do is we take trays of soil, those are 2 by 3 foot trays of soil, about 2.5 inches deep, and we try to put different management practices in each tray, and then we rain about 1 inch, 1.5 inches, 2 inches, whatever time allows, to show how rainfall can significantly impact different management practices. And we'll start over here on the left. This is a permanent vegetation. Could be permanent no-till with cover crops, could be permanent native grass. In either event, we show not only how much rain runs off, which is what these first jugs in the front represent. We can also show how much water actually infiltrates through that soil, represented by the jugs in the back. So if we start here on the left, we notice that we had a small amount of runoff. We had a small amount of infiltration, but at the same time, this soil, which is considered a fairly healthy soil, actually soaked in and absorbed the majority of that water. It caught that water where it needed it the most for use later. It acted like a sponge. Moving over to the second from the left, this is an example of what we would call quote unquote conservation tillage. The old idea, the old way of preparing wheat ground for farming was they would burn the stubble off and then really plow that soil up, get it really nice and fine. Conservation tillage was a method of just tilling that thatch, tilling that residue into the soil. But as you can see, it still has some open soil exposed to the elements. So we had quite a bit of rainfall, had quite a bit of runoff, and then not very much infiltration in the jug behind. I know it's a little hard to see. If we go over to the third from the left, this is a jug this is a tray of soil that is 100% covered from the residue. And we had absolutely no runoff and quite a bit of rapid infiltration. In a best of both worlds scenario, maybe that's not the way to put it, but in this case, I think we had a little bit too much water go too quickly through the soil. It didn't quite get as much captured in that top 2 inches as I'd like, but hey, it's going in the soil versus running away from the soil. And then here at the very end, this is traditional high intensity, high tillage agriculture. They chink that soil over and over, get it nice and soft and powdery. And this is just unacceptable. The amount of runoff and the amount of soil that goes with it. And with that soil is my nutrients, my nitrogen, phosphorus, potassium, secondary nutrients. That ends up in our waterways, causing water quality issues. And then our jug that shows how much water infiltration we have, very minimal. We're spending a lot of money, tearing up a lot of ground, leaving a lot of ground exposed, and not getting much result for it. So there's definitely some methods that we can incorporate using soil health to remedy that. Even with our grazing options, from 1930s to 2010s, we really haven't learned our lesson. We're still taking way too much grass, and through that taking away that protection that grass provides. Grazing management the last couple decades have really been trying to leave 50% residue height to protect that soil, allow root growth, to open up pathways for water to soak in. But we're still not learning our lesson. From 1930s to 2010s, we're still seeing a lot of improvement to be made. So that brings us to soil health principle number 2. I touched on it a little bit with our soil health rainfall simulator, but soil health principle number 2 is to minimize disturbance. Now, when I discuss disturbance, we're talking in farming, that's mechanical disturbance. That's the physical act of impacting the soil. We are turning it up, plowing it over, raking it, shredding it. And what that does is the negative impact is that destroys that soil structure. Soil has inherent structure that is formed. Earthworm channels, root structure holds that soil together. So when we destroy that structure, we can increase soil compaction. We can increase density of the soil, taking away pore space, and that limits water infiltration and even the ability for roots to grow. On the other hand, we have biological disturbance. Overgrazing, that's the physical impact of too many cows in too long of a period, reducing plant growth, trampling that soil, smushing that soil structure, can really cause a lot of damage, especially in wetter areas of the country. Herbicides is another biological disturbance. You know, when we go out there and spray a chemical and kill something, we can reduce the biologic capability of that soil, and that's a disturbance as well. Notice it doesn't say eliminate disturbance at the very top, because we have to cause a disturbance in some form to get a desired result, whether we're grazing livestock or planting crops. What I like to say is we optimize the disturbances that we make. You know, if we're going to disturb the soil, let's seed and fertilize in the same pass, or let's alter how we graze our cows or other livestock through short duration, high intensity grazing. So if we do have a biological disturbance, it's short lived. I like to say, take away our broadcast herbicide programs, and let's be a little more targeted in how we spray those plants. All different things we can think about, because nature probably already has a pretty cool system designed to correct anything that we disturb. You know, earthworms are a huge part of that. They can break open soil compaction. They can dig little tunnels. You know, if you look at the lower right picture, that is a picture of soil from a pretty dry spot in Kingfisher County that within just a couple years of just stopping the disturbance of that soil, a lot of earthworms dug a lot of channels, so much that they tripled the water infiltration on that particular field. That field went from taking in, I think it was 4.5 inches of rain per hour to 12 inches of rain per hour. You triple the amount of water you can soak in, you triple the amount of water you can hold, you can drought proof your farm or your field in some cases. So that brings me to soil health principle number 3, and that is to maintain a diverse plant community. Plant diversity is really obvious when we look at our native prairies. Go out in an unsprayed, undisturbed native prairie, and you can find upwards of 150 different species. You know, grasses do make up the bulk of those, but forbs and legumes that, although are a minority species, have a lot of different jobs in the soil, even though they may not taste good to livestock. You know, a lot of the plants that we consider weed species, in a lot of cases, when weeds start taking over a plant community, that tells me that there's something ecologically wrong that the weeds may just be trying to fix. Now, this is native weeds. This doesn't include exotic invasive species. That's a discussion for another day. But our natives, forbs or legumes that start taking over pastures or fields, that's an ecological indicator that says, hey, what am I doing to cause these plants to overtake my desirable species? A lot of these diverse species provide secondary and trace nutrients. Legumes like peas, beans, clovers, they can generate nitrogen in the soil, provide a free source of nutrients that we don't have to pay for. Some sunflowers and aster species can pull up what we call base nutrients like calcium, magnesium, and zinc from way deep down in the soil profile that, for instance, grasses cannot reach with their root systems. And then cows will eat weeds. It's like little kids in broccoli. It's nutritious, it's good for them, may not taste very good, But if we can manage how we graze our livestock, can certainly get some cows to utilize some of those plants, certainly in certain periods of the year or the certain periods of the growing season. One common misconception is that these weedy species will compete with our grasses. They each have their own ecological niche. They have different root shapes that utilize different parts of the soil profile. Like I mentioned earlier, those long tap roots of sunflowers or asters can reach deeper in the soil. And we've shown research through Oklahoma State that says spraying weeds does not increase your grass production. Here's a study from 2000 to 2005. This was done at the Marvin Clemmy Research Range out in western Oklahoma near Bessie. And they had a control pasture where they just kicked a bunch of cattle out and then tracked average daily gain. And then they had a herbicide treated pasture where they tracked the same data. And across the board, there was absolutely no statistical variation between the control pasture where they didn't do anything and the herbicide treated pasture where they sprayed all the weeds. So they got absolutely no increase in daily gain, so no increase in profit, but they still incurred the cost of that herbicide treatment. So there's always something different that we can do when it comes to looking at our soil health principle when it comes to weed treatment. A lot of cases, we make sure our cows can utilize some of those weedy species. That's bull nettle there on the left and buffalo gourd on the right. Now, this example comes from a producer in southwest Oklahoma who he stopped feeding his free choice mineral supplements. And when those cows didn't have those salt blocks or those mineral supplements, they went out and free choice selected some plants with an inherent high mineral content. The nettle and the gourd, they have a lot of salts and a lot of nutrients in those plants that those cows actually went and seeked out. And that's pretty neat. You got weed control and you reduce your mineral bill. So moving on, that brings us to our soil health principle number 4, which is keep a living root in the soil. It says year round, but for as much of the year as possible. That really ties in with soil health principle number 3, that plant diversity, having cool season varieties in warm season pastures, or vice versa, incorporating summer plant species into cool season crop systems like winter wheat, coming right behind winter wheat harvest and planting a summer grazing crop. Because not only can we increase our grazing or our crop growing days if we manage it correctly, soils have a lot of microbes and funguses and other critters, I'm going to say, that live in that soil that rely on plants and plant roots to survive. A big one is what we call root exudates. That's just sugary water that oozes from the plant roots, and it feeds microorganisms and other species. It attracts certain microorganisms that can cycle nutrients. The fungus can actually wrap around or wrap into plant roots to increase nutrient absorption, water absorption. But we can't have these root exudates if we don't have a living root in the soil. So if you take winter wheat, for an example, we plant that wheat in September. It goes from September to, let's say we harvest it June 1st. And then if those microorganisms in that soil don't get a living root, they can't survive. So we're asking that soil to basically starve from June 1st until we plant our next wheat crop in September. And it's baking under the hot sun in the hottest part of the year. So the only microorganisms that can survive in the soil in a wheat crop have to starve half the year, and then they have to be able to only eat wheat and nothing else. That's a pretty hard life to live, if you ask me. So looking more into our living roots in the soil, this is a summer cover crop mix that was planted into a winter wheat field. And here you can actually see some of the stuff. It looks like a fungi of sort that is growing in that soil. And we can actually, in grazing instances, extend our grazing system through incorporating cool season or incorporating other species to keep a living root in that soil. We can harvest that as a grazing crop, either with a cow or with a hay cutter. We can provide nutrient cycling, getting the most out of the nutrients that we apply in that soil. And then the most important, I think, is keeping our worms alive. Earthworms are one of the biggest indicators of soil health that you can ask for. If you don't have worms, you don't have healthy soil. Let me go back here. You remember the picture that I showed you of the earthworms burrows in that soil? Earthworms can. This was a discussion we had the other day. Soil that does not have earthworms can only infiltrate about 2 inches of water, whereas soil with 100 earthworms per square meter can soak in 12 inches of water. So just by maintaining a happy place for earthworms, we can increase 6-fold the amount of water that we can soak in. We're going to jump to soil health principle number 5. And number 5 is to incorporate our livestock, and I put in parentheses there, wisely, because a lot of cases we can incorporate livestock, but if we don't manage it, we can sometimes cause more harm than good. But we want to incorporate livestock because, especially in the Great Plains, and in some cases other ecoregions, prairie soils evolved under a pretty significant grazing impact from bison. But it was never a continuous impact. When we think about how the bison moved across the prairies, just think about the southern great buffalo herd. Millions of buffalo resided in this herd, and they would start, let's say, from the Concho River in Texas, and they would start grazing north with the growing season, and they would have a huge impact. Millions of animals grazing and stomping and urinating and defecating, but this herd was continually moving. So they weren't continually camping out on the same area. They would graze an area off and then move on. That space would have months to years to recover, recuperate, regenerate. In our soil health systems, we use rotational grazing to kind of mimic that system, albeit at a very much smaller scale. We try to look at a rapid harvest, but that long rest period allows that soil to recuperate, to regenerate. Think about your front yard as well. When you mow your yard, you're taking it pretty short. But especially if it's nice and rainy, in 2 weeks, that grass has grown quite a bit. Even a month, imagine if you left it 2, 3, 4 months, that grass has an amazing ability to recover, but we have to give it that opportunity by rotational grazing and not allowing those cows or other livestock to camp out in the same area. Another thing we don't think about very often is the biology of that rapid, heavy impact, long rotation, and that is dung beetles can recycle nutrients and can reduce habitat for flies. Let me stay right here real quick. When you graze those animals in a small area, they urinate, defecate in a small area, but then if you move them off pretty quickly, you can actually move your livestock away from problems with coccidiosis. Cattle will ingest bad stuff for them, and then you can, by moving cattle away from the manure, the cows are not inhabiting the same space that flies are reproducing, you can reduce some fly cost. Sticking with our continuous impact theory, I love this graphic and I love this tagline. It says, cows are lazy because we allow it. You know, we talk about grazing utilization, or the ability to harvest the most grass for the least amount of work. This is an Edwards Plateau region of Texas. There was a 3,000 acre ranch where they put GPS units on cows, and then they tracked how those cows utilized that pasture. And there's sure enough some elevation change and some vegetation change. But what I want to point out is only 39% of this pasture ever saw a cow. Cows never stepped foot on 61% of this ranch. That is crazy. When you think about how we set stocking rates for livestock, and then for them to not even use 60% of it, that is not efficient at all. But then, out of the 39% of that pasture that they actually utilized, 41% of those GPS points were total on 9% of the total area. And that's just, it is such a heavy impact. But in those continuous grazing systems, that a lot of the time, that's what we see. We see some areas absolutely untouched, other areas extremely overgrazed. And then over time, all the good, tasty, palatable species are grazed out and then are replaced by undesirable plants, just from how those cows had free reign over that pasture. So like I said, we want to mimic those roaming bison. In our conventional grazing system, those cows have no incentive to utilize other areas. They have no incentive to maybe take bites of less palatable stuff. So when you put cows in a smaller area, not only do you get more even utilization while giving 3/4 of the other pastures rest, there's a competition variable. You know, a cow comes along and says, oh, I better eat this, otherwise my neighbor will. And maybe incentivize those cows to take bites of stuff that they generally wouldn't. Western ragweed is one that comes to mind. A lot of farmers and ranchers that say they have problems with Western ragweed, it's in open untended access. Those cows never have any reason to take a bite out of it. Now, Western ragweed is 22% crude protein throughout the growing season. So if I can get a cow to take a bite out of it, other than spraying or brush hogging, it's worth looking into. Here's some examples of, on the top of a heavy continuous grazing system. That's a creek bottom that's been completely denuded of vegetation. So even if you do get any rain, for one, our soil is not covered. We're having some pretty heavy disturbance with the cattle hooves impacting the soil. We don't have a very diverse plant community. We don't have very many living roots in the soil because we have bare soil. So we're not incorporating our livestock very wisely. We're not following any of our soil health principles up there at the very top. Same spot several years later, after incorporating those soil health principles, we have soil 100% covered. We have a diverse plant community. Looks like we have plenty of grasses, forbs. Hopefully there's some legumes in there, even some woody species. That soil is minimally impacted. Whenever we have a grazing event, it's quick and they have a long time to recover. Depending on the plant community, it looks like they would have some cool season plants in there as well, hopefully to extend that grazing and keep a living root in that soil. And obviously the livestock are being incorporated wisely. So now we have water and carbon dioxide going into the ground versus water and carbon dioxide leaving the ground. So not only am I making more money, but I'm also helping out the environment. It's a crazy thought, isn't it? Going back to our dung beetles that we mentioned earlier, this is just a graphic that shows how different dung beetles can facilitate those cow pies. Some of them ball them up and move them around. Some of them bury them deep in the soil. In any case, they are recycling those nutrients, putting them in the soil, And even if the little dung beetle babies don't eat all that manure, a plant root is gonna find that tunnel, find that little ball of nitrogen, little ball of nutrients, and use that to grow. And then there's no opportunity for flies to lay eggs in that cow pie. There's less of an opportunity for a cow to come along and bite grass next to that manure pat. So just by managing your grazing, not only can you reduce your fly impact, you can increase the nutrient cycling. You're spending less money on fly spray, and you're helping the environment in the process. It's all good stuff, isn't it? So we're going to break it down a little bit more. Let's talk about the benefits of soil health. One of the big drivers of following soil health is we want to increase the organic matter of our soil. At the very first, we can say that 1% increase in organic matter can hold 20,000 gallons more water per acre. Now, organic matter is the carbon-based stuff, is the dead and decayed plant matter that it becomes part of that soil. So native prairie soils had anywhere from 3 to 5% organic matter. A lot of traditionally farmed agricultural fields in Oklahoma today have less than 1% organic matter. They don't have very much water holding capability. So each 1% increase across 1 acre can hold 20,000 gallons. How much more water can you hold on a 160 acre farm field by increasing your organic matter by 1%? Let's just do the math real quick. So if you take 160 acres, multiply that by 20,000 gallons of water, that is 3.2 million gallons of water just from that 1% increase of organic matter. Let's say we get really crazy and increase that organic matter content 2, 3, 4, 5% even. Guys, you just drought-proof your farm field or your grass field by increasing your organic matter. We drought-proof the farm. And at the same time, the more water that's staying in my soil, the less water that runs away, carrying soil particles, nutrients, nitrogen, phosphorus, potassium. We can increase our water quality at the same time. That soil stays in place, it's absorbing that water quicker. Here's some other figures from other fields. Healthy soil that can absorb 10 inches of rain in 1 hour. Thankfully, we don't have very many 10-inch-an-hour rain events, but in healthy soils that have those 2 to 3 inches per hour downbursts, they're grabbing all that water and they're holding on to it, versus those unhealthy soils that can't absorb a half an inch. They get a half an inch of rain, and it's essentially they got no rain because they couldn't even absorb that within 1 hour. And then we can talk about our input costs. Every time we look at adapting soil health principles, we can reduce our inputs. No-till farming can reduce fuel costs because we're not driving the tractor 3, 4, 5 times a season plowing or tilling soil. At the same time, it reduces the time you spend out there. What's your time worth? In our grazing applications, we can reduce our hay inputs, reduce our hay needs, and also the fuel and time it takes to harvest that hay. I know as a child, I spent a lot of time in the hay field in the summer, cutting, raking, baling, hauling, just to turn around in the wintertime, haul that hay right back out to the field, do a little bit of planned grazing, stockpile a little forage in the field, instead of hauling a trailer out there twice a year just to haul 10 bales of hay. We can take one trip with the cows, kick them out on the grass, and let them go get it themselves. A friend of mine from Australia who was listening to an event one day, and we were talking about how we continually hay our cows during the wintertime. And he put it so bluntly, in my terrible Australian accent, he says, "What's wrong, mate? Your cows don't have 4 legs?" And it was so simple. We spent all this time harvesting this hay, all this mechanical inputs and fuel and time, just to bring it into the barn and then to take it right back out in the wintertime. Seems so silly now, but we've got a hay habit in this country I think we need to kick. So when we come to our bottom line, we're trying to reduce our loss of soil, which we rely on for our livelihood, while increasing the water holding ability of our farm, whether it's cropland, grazing land, drought proofing that farm to grow more stuff. You know, at the same time, we're reducing our inputs, whether that be fertilizer, herbicide, fuel, mechanical implements, time, and we can actually regenerate that land. We can regenerate the ability of that land to function, not just sustaining it. Sustainable agriculture means we're staying at the same level. And at the same level of something that's been pretty beat up, I don't think is where we need to look at. I think we need to look at going in an upward trend, allowing that soil to increase the amount of work that it can do. And even in urban applications, we can look at how we landscape in our urban and suburban areas, you know, incorporating butterfly gardens or flower gardens of native species that provide not only beauty in pretty flowers for us to look at and smell and see, but the ecosystem functions that some of those flowering plants can provide. Habitat for pollinators. You know, we talk about the monarch butterfly is a threatened species because they don't have the milkweed plant that they rely on, because for decades, my family included, have sprayed indiscriminately and killed that milkweed out. Therefore, those butterflies don't have that habitat to lay their eggs on to reproduce. We can incorporate those into our systems. We can leave milkweed strips along the highways, allowing some of those butterflies to survive. And then even medicinal plants. There's a lot of medicinal plants that over the years we have kind of forgotten about. Mexican hat, certain species of thistle, certain species of deep taprooted plants that we didn't have Walgreens. We'd go out in the field, select those plants to smoke or steep in a tea or cure poison ivy in some cases, that we can try to incorporate in our diversity as well, always following those soil health principles. So I've got a couple parting thoughts. This presentation was geared more toward agricultural interests. So when it comes to weeds and weed species, and I have farmers and ranchers tell me, I have cows that won't eat this, that, or the other. I say, well, here on the left, there's a cow eating a plastic sack, so I'm pretty sure they'll at least take a bite out of it if you give them a chance. Don't try to tell me that cows won't eat something because there's one chewing on a plastic sack. And then here on the right, when we talk about making things work for you, this is a farmer running a cow down a road. I think that is a highly specified rotational grazing management implement. We could use that to, even in a small 1 acre area, we can increase our utilization and we can increase our soil health capabilities by controlling that rotational grazing. But it's just a funny photo of a guy that he doesn't have a trailer. He's using what he has make work for him. And that is what we need to look at with our soils, with our soil health capabilities, is take what you have and try to make it work for you just by following those 5 principles. So that is our presentation. I appreciate everybody here today listening to this. I hope you took really good notes because we have a test following this. Thank you all very much and hope you have a wonderful day.